Okay, so I encourage you. I'll try and set that up. I'll try and copy that link down. You said in the description part, and then you'll be able to click on that, and then you'll be able to play with some of those. There are other three-dimensional shapes that are on there, but for our sixth grade standards, we need to know triangular prisms and rectangular prisms only. Okay? And when we try to find that surface area, it might help to find the net. Now, I'm actually going to show you a different way to do it today, or another way to actually find this that might be similar, because we talked about how some of these shapes have congruent faces, or faces that have the same area. So I'm going to show you a little easier way to do it than to actually draw the net, but we should be familiar with nets because it could ask you which net below, and they'd have different multiple choice nets, would match up with the figure above. So we should get a little bit of practice with nets. So our job today is to be able to find surface area of this box. And everybody agree it's a rectangular prism? Can we all tell that there's how many faces would this rectangular prism have? How many faces? Yeah. Yeah, exactly, 6 faces. Because this front, even though we can't see the back, we know that there is a back that's back there, right? And this side, even though we can't see the other side, we know that there's another side. And there's a top and also a bottom. Okay? So one thing that we can do is actually to break this apart and create that net. And then find the area of each one of the faces. Or, can you close that, please? Thank you. Or, if we know there's a front and we know there's a back, can someone tell me what is the area of this front face? What's the area of the front face? Yeah. No, the area. The area of just this. When I say the front, I'm talking about this right here. What's the area of that? 12 feet. How did you get that? 3 base times height, right? So this is 12 feet squared, right? Now, if we know the front and the back, what's the total square footage of the front and the back? If the front is 12 feet squared, what does the back have to be? Back has to equal 12 feet squared. See, now I don't have to draw the net, because now I can go to this side right here and say, what's the area of this side? What's the area of it? 6, because we go 2 times 3. Okay, so one side is equal to 6 feet squared. What does the other side have to be equal to? 6 feet squared. Now let's go to the top. If it has a top, it has to have a... Okay, so what are the dimensions of the top? I can see 4 here. So I'm guessing that from right here to right here is 4. So here to here must be 4. How long is this from here to here? How do we know that?
Because the one over there is 2 feet.
Because of this one right here? If this is 2, this one has to be 2?
Yeah.
So what is the total square footage of the top?
8 feet squared.
8 feet squared. And then we have a top and a bottom, right?
The bottom is also 8 feet squared.
Oh, I forgot my squared here. I better make sure I include my label. And the bottom has to be?
8 feet squared.
I'll see you two after class.
No, I made that.
You did? And I'll see you after class. Thank you. Now, to find the total square footage, we can always combine like terms. And I'm going to tell you that feet squared and feet squared are like terms. I cannot add feet squared to just feet because feet squared and feet are not the same thing. If we look at, there's a difference between perimeter and area. Area says the total number of square units inside, and perimeter is just the distance that we have. So do you see how there's a big difference between 12 feet, which would just be a distance this long, and then 12 feet squared would be 12 feet wide by, or sorry, 12 feet squared would be like 4 feet by 3 feet. Okay? Rather than just having a straight line. There's a difference between the two. Okay? So we can combine these two and add them all together, and we'd find the total square footage, or we'd find the surface area of this shape. So 12 plus 12 is?
24.
Grand total of 24 here.
Plus 12.
And then we have a grand total of 12 here, plus 12 feet squared. And then we can combine those two if we want to and say it's 36 feet squared. And the next two is 16.
Wait, no. 52.
And we add them all together, and I should get 52. So all I'm doing is finding the area of each one of the faces that we have. I know for a fact there's 6 faces. Look at a front, 1, a back, 2, 2 sides, 3 and 4, a top and a bottom. That's 6 total sides. And because we know that the top and the bottom are the same, I don't necessarily have to pull and create the net. Okay? I showed you earlier how to make the net, and if you need to go back and look, go back to that web page, because I think it does a good job of breaking down those shapes to showing you what those actual nets will look like. Okay? Yeah. Only if it's an emergency. Now, we could actually be given a net. We could actually be given a net. This is what this is. It's a net. It's a 3-dimensional shape where if we wrapped it all together, that shape would look like, now keep in mind, my art grades were not great in school. Okay? I'm going to try my very best. Well, good for you. I did not get A's in art. Okay? I'm going to draw this line right here and say that that's my 5-centimeter line. Okay? And then I have a line. This is one that you technically can't see right here. But I need that to draw this piece here, this piece here, this here, and then we can see that right there. And this you wouldn't technically be able to see. So everybody see, that's what this shape right here would look like. Okay? And so based off of this, all I did is take this triangle right here and I flipped it up to create this right here. Okay? And then I took this shape right here and I flipped it up with this one right here to make this right there. And then this one right here is sitting on the back side. That's that side that we can't see. It would be considered the back. Does that make sense to everybody? So, I mean, I could go through and put in all my dimensions here. I know that this has to be 3 because that's how long this piece is right here. Okay? And then if I flip this up, I know that this has to be 4 centimeters high right here. And if I flip this part up, I know that it's actually, this distance right here is actually 3. I made this a little bit longer than what I really should have. And I know that from right here to right here is 5 right here. From here to here is 5. So my drawing isn't perfectly to scale here. I told you I wasn't very good at art. Okay? And then we should know that from this distance right here would also be 3. That dotted line right here would be the same as this one here. Okay? But at least you can kind of see. And maybe if I just erase and just draw it right here, it might be a little bit better and more up to scale. Okay? Yes, sir.
I have a question. Why do you not see like little lines?
See them?
Yeah, like,
Because this would block off this view of this dotted line right here. And like this right here, you wouldn't be able to see this because this part right here. Okay? So it's almost like we're, I guess if it was glass, you could see through and see it. Right? Okay. So just to show you, this is what the three-dimensional shape would somewhat look like if we folded it all together, wrapped it back up. Our job for surface area is to find the area of each one of the faces. Can you tell me what's the area of this triangle right here? Keep in mind, this triangle right here is the same as this one right here. This triangle right here. What's the area? Yeah. Nope, it's not. I'll give you a hint. It's not 12. We know that area of a triangle is what? What is it, class?
divided by 2.
Okay, your formula sheet will actually say 1/2 of base times height, but we know that that's the same thing because we know that multiplying by reciprocals is the same thing as division. That's equivalent to base times height divided by 2. So instead of being 12, it's actually what? 6. So this is 6. We know right here this is 6. Guess what this one has to be?
6.
It has to be 6. This piece right here means nothing for our triangle. It's always base times height, and our height always has to come from a right angle. Okay? So this one still is 6. So if you go back to what we said before, we know that we always have a front and we always have a back. So we would have two triangles at 6 centimeters squared. Whoops. And 6 centimeters squared. So now if I press too hard with my marker, then it shifts everything on here. Isn't that interesting? All right, now we need to find the area of this this rectangle right here. And I'll give you a hint. That's this rectangle right here. Okay? And I know that from here to here is 5, and from here to here is 3. So what's the area of this rectangle right here? What is it?
15 centimeters.
Yep, 15 centimeters squared. Now this one over here isn't exactly the same. This one is actually 3 by 4. Okay, so 3 by 4 is exactly 12 centimeters squared. And I better put in, I know that I have 15 centimeters squared and 12 centimeters squared. We only have one more face to go. Which face do we need to do? Yeah, the one that's right in the middle, and it's the one that we can't see. It's actually underneath here, right? Okay, and it looks like it's 3 here. How high is it here? 3 by 3, because look at it tells us right here that this is 3, so this one right here must be 3. Okay, so we have a grand total of 9 centimeters squared. Okay, everybody with me? Now, what do we have to do with all 5 of these faces? What do we have to do with all 5 of the faces? Since we have the areas, add them all together. Now addition's commutative, right? Right? So does it matter which order I go? No, so I'm going to go with 11 here, right? 9 and 2 is 11. Plus 5 more is 16. And then 6 plus 6 is 12. Can we do 16 plus 12? So then 28. One, 2, 3, 4. 48 centimeters squared. Now I could have just gone from this picture and gone right here. 15 plus 15 is 30, and then 12 plus 6 is 18. 18 plus 30 is 48. So it doesn't really matter how I do it. Either way, I have 48 centimeters squared. That would be the total surface area to create that object. Does that make sense to everybody? Now, surface area we use quite a bit, like if you're going to paint, let's say if we were going to paint that wall right back there, we need to figure out the total area of all the walls together to figure out what the surface area is. And then we'd have to figure out 1 gallon of paint, how many square feet does 1 gallon cover? And then we get into some really tricky math problems that way. But that's one way you don't just go to the store and say, hey, I need a gallon of paint and just hope that it's enough. Right on the gallon of paint, it will say how much surface area it will cover, how many square feet it will cover. Does that make sense to everybody? All right, we're going to try. Yes.
Just measure the base of it times the height.
Right, but just keep in mind there's, in this wall, or if I'm going to do all the walls, I'd have to find the area of just this section right here, and I'd have to discount where the heat comes out. And then I'd have to find the area of that section right there. So we're adding a couple different areas together. And then I'd have to I'd have to discount the door because we don't want to paint the door, do we? Otherwise, well, if we painted the door and the doorknob, we might not ever be able to find our way out.
Well, you never know.
Well, some of you would. And the same thing back there, we'd have to discount the door as well. Okay, but that's one way that we'd find. We'd have to find all those areas of the different walls or different sections and add them together to figure out the total square footage that we'd need. Okay,